Hello programming languages students. Welcome back for another Prolog video. This time we're going to talk about variables. So this is where we can really start doing some cool things with Prolog, and we can start to see some of the power behind the scenes here. So we're going to start with a simple database. We're going to have defined three women, Mia, Jody, and Yolanda. And then we're also going to define three other rules. Notice that there are commas here. So when you create these rules, these predicates, um, you can have multiple arguments. You can have one argument, as in this case, or you can have two or more, separated by commas. So this is just like arguments or similar at least to arguments in Java. And so this is just two different things that go into this predicate. This actually defines its arity. So we'll talk about arity, arity. Um, And basically, this helps us define functions and compare them. So we're going to define a predicate or a function called loves, and it's going to have an arity of 2. So arity, arity of two variables in it, or really this is two atoms because they're lowercase. Um, so these have two atoms. This is Vincent, Mia. So this is basically saying that Vincent loves Mia, Marcellus loves Mia, and then we have Pumpkin loves Honey Bunny, and Honey Bunny loves Pumpkin. So these two love each other. But Vincent loves Mia, Marcellus loves Mia. We don't know who Mia loves, but we know that there's two guys after her. So we're going to see how that evolves and runs through as we go through our knowledge base here. So you'll notice that so far in all of our videos, we've defined values or names or things that all start with a lowercase letter. This is a critical distinction. In Prolog, a lowercase letter means an atom. This is a fact. This is an actual value here. Capital letters, or things that start with capital letters, are called variables. And so I'm going to demonstrate what a variable does by first showing it as a query. So we're going to do woman, comma, x. Note that it's a capital X. That's very important. And so let's run this query. So what does this variable thing do? So capital X is anything that starts with capital is a variable. And you'll notice the first thing it returns is x equals Mia. So we have this variable x, and it's decided that if I'm looking for a woman with x, then Mia is a woman. However, now we have a next, 10, 100, 1,000, and stop. This means that there are potentially more women in our database. With a variable, you can have, it can find multiple things. So if I hit next, we're going to see that Jody is also a woman. And if I hit next again, we'll see that Yolanda is a woman. So, and then we stop, right? No more next, no more 10, no more 100. We found the last woman in our data set, in our database. So this is a variable, capital X is a variable. And so instead of just saying whether it's true or false, we're now seeing what could x be to make this true. So if we do woman x, what are the possible values of x that make this statement true? Well, Mia makes it true, right? Woman Mia. Jody would make it true, and Yolanda would make it true. These are the only three things that would make this statement true. And so it shows us all three of these as possible answers. So a variable shows us what is possible here. All right. So let's take this another step further. Let's do loves Marcellus x. So what do we think is going to come out here? We have loves Marcellus x. Under loves, we do have Marcellus loves someone, and the only person that he seems to love, the only fact we define that involves Marcellus loving something, is Mia. So if we run this, we get one answer, which is that x is Mia. So we found this rule. What if we do loves x comma Mia? So in other words, what's the whole list of people that love Mia? Well, we're going to get Vincent, and we're going to get Marcellus. All right, so variables can find a couple different things. In fact, when we make queries, we can do things like this. Marcellus x and woman x. Note that we've used the same variable x in two places. Within one statement, that means that this x must be the same thing. You cannot have an x that is one thing here and a different thing here, right? So if I run this query, with Control Enter, we find that x equals Mia. because Mia is someone that Marcellus loves, and Mia is a woman. So the next query, let's do loves pumpkin X and woman X. So loves pumpkin X, that should be Honey Bunny, right? That's pumpkin loves Honey Bunny, so that's who X is. And then we check woman X, there's no Honey Bunny is not a woman. And so what we're going to get here is false. Because although this should be true, loves pumpkin X can be true, it's only true if X is Honey Bunny. And there's not also a fact that says that woman, Honey Bunny is a woman. So we don't know whether Honey Bunny is a woman or whether it's not. We don't know. Um, so if we change this to an or, it would work, and Honey Bunny would be found. Um, Now, as it turns out, we also find Mia, and we'll talk about why that is, and Jody and Yolanda. So we actually get four things as true here. So why do we get four? Well, the first thing, we have loves pumpkin X. Well, this is true if X is Honey Bunny. So this is true, and since semicolon X is an or, we get X as Honey Bunny. We then also have the or that goes to woman and checks X, and so all the possible women would also make this true. Mia, Jody, Yolanda. So with an and, nothing makes this true. With an or, everything that is either, every person that pumpkin loves or every person that is a woman shows up as options. So, so again, this goes back to variables. What can they do? What can't they do? Let's make one more piece to this to make it a little more interesting. Let's see if jealousy shows up here. We got a little potential love triangle going on with Vincent, Marcellus, and Mia. Let's see what happens here if we talk about jealousy. So X is jealous of Y. Again, we can use, now I guess we're going to see that we can use variables over here in our database. This is important. We're going to do this a lot. This is very, very common. So X is jealous of Y if X loves Z and Y loves Z. So in other words, we're defining a rule that one person is jealous of another if the first person loves somebody that the second person also loves. Right? So if X loves Z and Y loves Z, then X is jealous of Y. So we've now defined this interesting jealous predicate. So let's jump into our example. Let's see who Marcellus is jealous of. Well, this is actually an interesting result, and we'll talk about why this shows up. But Marcellus is jealous of Vincent, and he is jealous of Marcellus. He's jealous of himself. Well, there's a lot to unpack here. A guy being jealous of himself, I don't know, we'll see why that's the case. But first, let's focus on why he's jealous of Vincent. So Marcellus, as the X here, would be jealous of Y, Vincent, if Marcellus X loves Z. Well, to make this true, Marcellus would have to love Mia, so Z has to be Mia. That means the Z also has to be Mia here, right? So we've decided that Z is Mia. Both of these are going to be Mia, so Marcellus, if Marcellus loves Mia and someone else loves Mia, then Marcellus is jealous of that other person. So Marcellus loves Mia, Vincent loves Mia, therefore Marcellus is jealous of Vincent. Now what's interesting about Prolog is it goes a step further. It says, all right, well, X and Y could both be Marcellus. There's no reason not to, right? So if Marcellus loves Mia and Marcellus loves Mia, well, if I make X Marcellus and I make Y Marcellus, then that's fine. We can do that. And he can be jealous of himself because he loves Mia, and he's jealous of anyone who loves Mia, which includes himself. Um, so this is a potential interesting point with variables, is that anything that could possibly make this true will make it true and will show up as an answer. So we'll dive into a couple more examples here. This problem, this thing, where we can have an X that's Marcellus and a Y that's Marcellus and a Z that is Mia, gets to a problem called unification. So we're going to talk about unification in our next video.